Okay, so this is the video lesson for derivatives day 5. We're going to learn two more rules, product rule and quotient rule. And so it says when taking the derivative of two quantities that are multiplied together, you must use the product rule. Okay, and so this is what the product rule is. When you take derivative of f of x times g of x, it is equivalent to the derivative of f of x times just g of x plus, and then you switch it around, just f of x times the derivative of g of x. So we can use this on problems where we could not use the power rule before. Now on number 1, we could actually multiply all this out and then use the power rule, but we can just as easily use the product rule. And if you're not really having to simplify your final answer, you're going to see in a minute why this is useful. Okay, so first what we're going to do, it's kind of almost like we're going to call the first part f of x and call the second part g of x. Alright, so let's take the derivative of f of x. Okay, so that's going to be 3 times 2, which is 6, and then we're going to decrease the power on x by 1, and the derivative of 1 is 0. Okay, now we are going to multiply by just f of x, so that's 3x squared plus 2x minus 5. Okay, so that's the first part. Now we have a plus. Now we're going to just write f of x, which is just 2x cubed plus 1, times the derivative of g of x. Okay, so the derivative of g of x is 3 times 2, which is 6, and the power on x is just going to be 1 because we went 1 less. The derivative of 2x is 2, and the derivative of negative 5 is 0. And you can leave your answer just like this. This is the beautiful part. Now, if we were going to do something else with this, then maybe it would be important to go ahead and simplify it, but we're not. Oops, that's not what I meant to do. Here we go. Okay, so now let's try something else. It says given f of x equals x squared cosine x. Now, if there's just a number in front of cosine x, I wouldn't have to use the product rule, but this is two separate functions of x. Okay, so you may even want to like separate them or something so that you know that these are two different things. Okay, so the f prime of x, the derivative of x, is going to be the derivative of x squared, which is 2x, times just cosine x. Okay, plus, now what we're going to do is we're going to do the other way around. Now, this time when I take derivative, I'm going to write x squared, and when I take the derivative of cosine x, that's negative sine x. So what I'm going to do is I'm going to write sine x, and then I'm going to change this plus to a minus by just erasing that little bit right there. Okay? And there is no other way to write this. That is your answer. Alright, now this says find the slope of f of x at x equals pi over 6. Now, we already found the derivative, so now we just need to plug in pi over 6. And we should be able to do this since we've reviewed our trig. So we have 2 times pi over 6 times the cosine of pi over 6 minus pi over 6 squared times sine of pi over 6. Okay, so let's think about this. This is 2 pi over 6. That's going to be pi over 3. And the cosine of pi over 6 is square root of 3 over 2. And I put a minus here, and that was a mistake. That should be a plus. I apologize. In the product rule, you're adding these two quantities. Okay, now I need to square pi over 6. So I'm going to go plus. That's going to be pi squared over 36. And sine of pi over 6 is sine of 30, which is 1/2. And so this actually would be okay. Since we're actually finding slope, it would probably be a little bit better if you went ahead and took it just a step further. And if we wrote this as square root of 3 pi over 6 plus pi squared over 72. We're not having a function. Generally, you can leave functions unsimplified, but numbers you want to try to simplify as much as possible. You could work to get a common denominator here, but this is fine. All right, now Looking at the next one, find the derivative of f of x if f of x equals cosine x times 5x squared plus 1, and then you see the rest of this. So we're going to kind of use a combination of product rule and power rule here. All right, first we've got to use the product rule on this part right here because those are two different functions of x. So I have f prime of x equals, okay, the derivative of cosine of x is negative sine x, and then I'm going to multiply that just by 5x squared plus 1. Get that looking like a squared. All right, now plus, this time I'm going to have cosine x and times the derivative of the second part. So we have cosine x times the derivative of f5x squared, which is 10x, and the derivative of 1 is 0. Okay, now minus x squared, well the derivative of that is minus 3x squared, that's the power rule coming into play, plus the derivative of 3x, which is 3, plus the derivative of 9 sine x. Now because this is a number, this is all considered one term. So you do not need to use product rule here because we don't have two functions, we just have a constant times a function. So this is going to be plus 9 cosine x, just like how we did with the power rule before. Now again, you do not have to simplify this out. Next year in calculus, you'll learn when it will help you to simplify and when it won't. Right now we're just getting the rules down. Okay, so let's look at this last one. Just like in power rule, when you see these radicals, it is going to help you to go ahead and write them in this way, x to 1/3. Now you could distribute this and use the straight power rule, but let's practice the product rule on something like this. So f prime of x is equal to, okay, we need to take the derivative. That's going to be 1/3 x to the negative 2/3 power, using the power rule, times just the second part, which here is acting as g of x. Doesn't like to do those exponents. All right, plus, and then we switch it around. So this time I have x to the 1/3 times the derivative of x squared, which is 2x. And there you go. That's your answer. No need to simplify. Okay, now we have something called the quotient rule. All right, it says when taking the derivative of two quantities that are being divided, you need to use the quotient rule. This is a little bit more complicated. If you notice, here I have derivative of f of x over g of x, and the top part looks like the product rule, but with a minus sign. Okay? And in the denominator, we have g of x squared. Now, I want to point out one thing. In the product rule, it wouldn't really matter if you got these two things switched. All right? Meaning all of this switched with all this, because it doesn't matter if you add things forwards or backwards. But when you're subtracting, it definitely matters. So a little rhyme, it's not really a rhyme, but it's a nice little saying that may help you, is we call it low d high, just write this off to the side and I'll explain it, minus high d low all over low low. And I've heard lots of rhymes. You can Google quotient rule sayings and they'll show you lots of little stories that could go along with this. But what it means is you're doing the low function, meaning the denominator, times the derivative of the high function or the numerator first, and then minus the high function or the numerator times the derivative of the low function over the low function squared. Okay? So if you say this every day, if you're that type of person, then you'll remember it very well. Okay? So now let's do this with this first function. Let's find f prime of x. And it does say to simplify the numerator of the derivative, so since it says it, we will need to do it. Alright, so first we need to do the derivative of the top, the numerator, times the denominator. Alright, so the derivative of the numerator is 5. The denominator is going to be x squared plus 1. Alright, minus. Now we need to switch it up. Now we need to do the derivative of the denominator, which is 2x, times the numerator, 5x minus 2. This is going to be all over x squared plus 1 squared. So we do not need to multiply out the denominator, we just need to simplify the numerator. Alright, so this is going to be 5x squared plus 5 minus 10x squared plus 4x all over x squared plus 1 squared. And then one last step to simplify. I'm going to do this over here. We end up having negative 5x squared plus 4x plus 5. Now if you notice that I have this trinomial left, you might be thinking, well, could that simplify with the denominator? And it's definitely something you could check for. It's not really going to be a big issue right now, but it's good if you were thinking that or if you were looking for that. Okay, let's do another one. So again, to find f prime of x, we need to think low d high. That means take the derivative of the numerator. That's going to be 3 cosine x times the low, or the denominator. So we'll write this 2x cubed plus 7x. All right, minus high d low. So we're taking now the high function times the derivative of the low function. Okay, so I'm going to go ahead and write the 3 sine x first, because it seems like that will fit naturally better first. And now we take, using power rule, we take the derivative of the denominator, 6x squared plus 7. And remember, don't ever forget the denominator. You got to remember that. And we're just going to write it as 2x cubed plus 7x in parentheses squared. And it didn't say to simplify, so there you go. There's your answer. All right, now we do not yet know what the derivative of tan x is. You're about to find out, and I'm going to go ahead and point you down here. You are going to want to memorize these, all right? Otherwise, you're going to have to use quotient rule every time. So we're going to use quotient rule first, and I'm going to rewrite this as f of x. You might be thinking quotient rule won't work, but if we rewrite it as f of x equals sine x over cosine x, now I can use the quotient rule. So f prime of x. Okay, again, think low d high. So the derivative of the numerator, which is cosine, times the denominator, which is also cosine, minus, okay, now I'm doing high d low. So I'm taking the derivative of the denominator times the numerator. So that's going to be a negative sign, so I'm going to put a plus there. Sine x, whoops. I'm kind of getting a little ahead of myself there. And all over the denominator squared. So I'm going to just write that as cosine squared. Now let's think about this. This is cosine squared plus sine squared. What is that? That is 1. Using that Pythagorean trig identity. And what is 1 over cosine squared? It is secant squared. So it turned out maybe not to be what you expected, but it simplified quite nicely. All right. Cotangent is going to work a similar way. You're going to get to practice that on your assignment. All right, now let's do secant. So again, I'm going to rewrite it. This time I'm going to write it as 1 over cosine x. And I'm going to use, even though this is a 1, I'm going to use the quotient rule, because I've got no other way to find the derivative. Okay, so low d high. So what's the derivative of the numerator? 0. So you could go ahead and write times cosine x. It doesn't matter. It's still going to cancel. Okay, minus. All right, now we need to take the derivative of cosine x times 1. That's going to be negative sign, so I'm going to put a plus there for that. All over cosine squared. Okay, so that goes away. And what we're left with is sine over cosine. And there is a times 1 here. I didn't write it. Don't want anybody to get confused by that. All right, let's think about what this could look like. Let's break up the denominator into actually writing out cosine. All right, what's sine over cosine? Tangent. What's 1 over cosine? Secant. So again, maybe not what you expected. The derivative of secant is tangent to secant. Okay, and cosecant works out very similarly. You're going to see that on your assignment. I'm sure you have questions. Please bring them to class.